we have derived the formula for refraction at curved surfaces, and we have actually got two sets of formula. One is from denser to rarer, another from rarer to denser, right? And
Yes,
the
sir.
next thing which we have done was this lens maker's formula. So lens maker's formula, and the refraction at a curved surface. So all these are very important derivations, and even you
Yeah.
can expect questions to be asked on these formulas, right? And the lens formula can also be derived from, or you can derive it directly without actually going through the lens maker's formula. So we'll see that as well. And once we are done with that, then we'll move to magnification and other things. Okay. So I hope you already know basics of image formation or in
Yeah.
refraction, right? What is focus? There are two focus in a lens. Are you aware of that?
Yeah.
Principal, I mean, first principal focus
Second is
and second principal focus. So what is the difference between these two?
first is towards on the side of the object. Second is towards the side of the image.
Okay.
So it's where second. So first is when the incident ray passes through the lens. So second is where the refracted ray joins to form an image. So like that.
Okay. See, the first one, right? The first principal focus is the point, obviously, on the principal axis of the lens, at which, if an object is placed, suppose if the object is placed at this point, which is focus. So if you place an object at this point, then the image will be formed at infinity,
Infinity.
right? That means what will happen here? We know that if a ray passes through focus and is incident on the lens, then what happens to this ray after
It will pass
refraction?
direct. Yeah.
What happens?
After
It be,
it won't. Yeah, it goes parallel to the principal axis.
it goes, yeah, it becomes parallel to the principal axis. So this is the first principal focus, right? So object should be kept there, and if an object is kept there, then the image will be formed at infinity. Now, how will you draw this same scenario or the first focus in convex lens? Suppose this, sorry, convex lens we are done. What if we have a concave lens like this? So where will be the first principal focus? So as I said, object should be kept at a point on the principal axis. So let's say this is the point where you have the object. Then what will happen? Where will uh, the image should be formed at the infinity? So that means this is possible when you have a light ray coming towards focus like this. Okay, so this is the original path of light, but after refraction, because it is a diverging lens, so what will happen here? Because it is a diverging lens,
Bend.
so the ray will become parallel to the principal axis. So this is the situation of focus 1, that is first principal focus in both the cases. Coming to second principal focus, second principal focus is that point on the principal axis of the lens at which the image is formed when the object is at infinity. So first principle is what? Object will be at first principal focus,
Okay.
then image will be at
Infinity.
infinity. And it is the reverse case. That is, if object is kept at infinity, then where you will get
And
the image?
focus.
It will be at
At
second
the second
principal
focus.
focus. So that is the only difference, right? And these two are also the rules of refraction when you are studying these lenses. So if the light ray is coming from infinity, those light rays will be parallel, and the parallel rays, when parallel to principal axis, they, after refraction, they converge at focus, but that focus is second focus or second principal focus. So if you take the same example of a convex lens, the rays coming from infinity, right, they will actually converge at a given point. That point is nothing but the second focus.
Focus.
Okay, and what about the second case? The same thing, that is case of concave mirror. Here also you'll get the same thing, that is, the light rays will be, the incident light rays will be parallel. That means they are coming from infinity. But what will happen to these light rays? They won't be able to converge. They here
Yeah.
will actually
Different.
diverge. And
Yeah.
when they diverge, they appear to diverge from a
From.
point. That point
Yeah.
from which they appear to diverge,
Yeah.
that is called
F2.
the second principal focus, right? So that is about
Yeah.
these two different focus. Now coming back to this lens formula, this lens formula is also called thin lens formula. That means the lens is, the lens which we are on, which this formula is applicable, that is a thin lens. For example, the lens which you see in your eyeglasses, they are thin lens. Okay, so we will try to derive this formula using the image, right? How the image is formed in a lens based on that. So it will also give you an idea of how to draw the image in case of a lens, and the same rule we will be following in other cases as well. So as we have seen, we have two surfaces here. Let's say this is the lens, it has two surfaces, and let's say both the surfaces have same radius of curvature, although it is not looking like that here, but that is what we have this actually, right? The simplest case.
Yeah.
Okay, now it will have two focus, we know. On this side, this is focus 1, this is center of curvature. And what is the relation between center of curvature and focus? So center of curvature, the distance from the pole to the center of curvature is twice that of the
Pole.
distance of focus from the center, sorry, the radius, yes,
Radius of
yes,
curvature.
basically radius of curvature is twice of
The
focal length.
focus. Focal length.
Yes, so this is the point where you have 2f1.
2F.
You say 2f1 or center of curvature, let's say c1. Let's say this is the center of the lens C, and what else? You will have to focus on this side, focus on this side as well. Let's say this is f2, and similarly you have 2f2 here, which is nothing but c2 or center of curvature of the second, on the second side. Okay, now suppose the object, in the most general case, that is object is kept here. So object is here, where object is between focus and the center of curvature. So from this, there will be multiple
Beyond
rays.
2F.
Yes, there will be multiple rays incident from this object to the lens. So let's, about B we will talk later. Let's consider this A point. So from A point, there will be various rays
parallel
against
rays.
them. One of them, let's take parallel to the axis. So what will happen to this? It will pass through the focus.
Pass the focus.
After refraction, it will pass like this. The second ray we can take to pass through the center of curvature, and if it passes through center of curvature, what will happen to this? It will go,
So optical center, right?
yes, optical center, not center of curvature, sorry. So it will go as it is, it won't
Yeah.
refract, it will go like this. And now these two rays after refraction will, as you can see here, intersect each other. So where are they intersecting? They are intersecting at this point. So this
Yeah.
point where they have intersected, this is the point of intersection of rays coming from A. So let's represent them by A dash. Similarly, this point, this point, this point, every point on AB will have an image here. And what will be the image of B? You can think of the ray passing through this and like this.
Yeah.
So nothing else, right? So this will be the image of B dash. So now you have A dash B dash. So AB is the object, A dash B dash is the image. And let's say this point belongs to the lens. Let's say this point is given by M. Now you have many triangles formed here, and we'll be using those triangles only to find the to derive the lens formula. So we'll see that later. For the time being, various things which you can see here. For example, this center of curvature to the lens, the distance is given by r, that is radius of curvature. Similarly, this length, that is distance to the focal
Yeah.
focus, that is focal length. Similarly, the object is kept here, so its distance from the pole
U.
is nothing but
U.
u. And what else? You have v.
V.
V is this distance is nothing but v. So
V.
these are all the distances. So we have all the points and the distances. Now what we have to do is we have to derive the formula. So this is how the image formation you have to show. Coming to the derivation of formula, you can see there are many triangles here. So we'll take the triangles involving few
UV and
sides here,
X.
especially, yes. So one of the such pairs is triangle ABC. So when you
Yeah.
say triangle ABC, you take another similar triangle. Another similar triangle will be triangle A dash B dash C. So these two triangles are similar. That is A,
Yeah.
B, C, and A dash B dash C. That's because this angle is equal to this angle. This angle is 90 degree. Then the third angle will also
Yes.
be equal. So these two triangles are similar triangles. And if these two triangles are similar triangles, that means A dash B dash divided by AB will be equal to, in the second triangle, if you take say CB dash, that will be equal to divided by CB. Okay, what is A dash B dash? That is the length of the height of the image. AB is the height of object. CB dash and CB, so CB is image distance and CB dash is the, sorry, CB is object distance and CB dash is the image distance, right? So this is one equation. Now take another pair of triangle, that is where we have to now relate focus, right? So focus is here, and which triangle is formed by this? So it is this MCF2. So MCF2 and AB, A dash B dash F2. So triangle MCF2 and triangle A dash B dash F2.
See.
So these two triangles, right? Again, we will try to include the image length here. So image length is nothing but A dash B dash in the second triangle. So A dash B dash in the second triangle will be corresponding to MC in the first triangle. So that ratio should be equal to, in the second, try to bring focus into picture. So this is B dash F2. So B dash F2,
by
sorry,
B. A
B
dash
dash
B dash.
F2 you have taken. So B dash F2 you have taken in this triangle. So here you'll have to take CF2. If you write triangles in order here, you will not have to see the diagram again while forming this statement. Both the triangles are written in same order, right? So that's why I don't need to go back to the diagram and see what is the order or which are the corresponding sides of each triangle.
So is it CF2 or A? How
See,
is it CF2?
where is this is B dash F2, right? In the what are the two triangles? You understood which two triangles I am talking about?
Yeah.
And this triangle and this triangle.
Oh, yes, sorry. Okay, got it. It's from two triangles, right? Yeah, I didn't see
Okay, so now you
that.
have two two equations from these two pair of similar triangles. Next, what do we have to do? So if I have to find a dash b dash by ab, as you can see here, so that is equal to cb dash divided by cb, and the second one, if you see the second one, right, a dash b dash divided by ab is equals to
Dash B
ab,
dash by
and
AB.
so ab and mc are of same length, right? The length of AB and MC is same,
Yeah,
right? So that means here also you have AB.
yeah.
So from this you can also say that A dash, I mean the second equation is what? A dash B dash divided by
By
AB
AB.
is equals to B
B
dash
dash
F2
F2 by
divided
CF2.
by CF2. So
So
A
you're
dash,
comparing both equations.
yes. So this is your second equation. So that
Yeah.
means this,
CB dash by CB is
these
equal
two
to.
are same.
Yeah.
Okay, so that means cb dash divided by cb, which is nothing but v divided by u, right? Image distance divided by object
Dash
distance.
F2.
So that is equals to b dash f2 divided by cf2. Now cf2 is focal length, but what is b dash f2? So b dash f2 is this distance, that
Image.
is distance between the focus and this. So what is this distance? This distance is simple.
R.
This is b dash f2 is nothing but
2F.
cb dash minus cf2,
2F. Yeah.
cb dash minus cf2, that will give you
Yeah.
this f2b.
Yeah.
So b dash f2 will be that. So now let's write that.
2F plus something.
That means this cb dash divided by cb can be written as cb dash minus cf2 divided by cf2, right? So we had this sign convention, so you apply the sign convention and all the symbols there. So what will be cb? What will be cb? Is cb c to b, is it minus u?
Yeah.
Cb dash will be plus v, and
CB
cf2,
dash. Yeah.
that is the only thing left. cf2, c2 f2, which is on the right hand side, so that's why that will be equals to the focal length.
F.
So v and f will be plus and u will be negative. If you substitute
Yeah.
this, what you will get plus v divided by minus u, that is cb, is equals to cb dash again, v minus cf2 is nothing but f divided by f. Now you have to simplify this. So in order to simplify, what we are going to do is, we know what
Divide
final
and multiply
expression
by
we will
v.
get, but still to simplify, yeah, what were you saying?
Divide and multiply by v.
Divide and multiply by v. Okay. Okay, first
Then
I'll simplify the right hand side first. So this is u minus, v by minus u is equals to v by f minus 1 by,
or just
minus
remove
1.
yeah v by f by 1 by yeah
Now I'll divide it by v on both the sides. So it will remain
yeah
same. So if you divide it by v on both the sides, you'll get minus 1 by
1 by
u is equals to 1 by f minus
f
1 by
minus
v.
1 by v.
That means 1 by v minus 1 by
1 by u
u is equals to 1 by
1
f.
by f.
This is called the thin lens formula. This is the final expression. So again, as you see, this is all geometry here. Like what we
Yeah
have done here to here, we multiplied it by 1 by v on both the
yeah
sides. So this is your lens formula. Any doubt in this?
no
Okay. Now the same form, in continuation with this, to this, we have next topic, that is linear magnification.
amplification.
So linear magnification means,
It's an
uh,
h by h.
yes. So basically it is magnification only in terms of the height or the length. So linear magnification produced by lens is the ratio of size of the image to the size of object. So magnification m is equals to the image size divided by object size. So if it is magnified, that means if the size is increased, right, from the original object size, then the magnification will be greater than 1, otherwise it will be less than 1. Or you can say positive or negative as well. Okay, so that means if you compare to the previous diagram, it will be a dash b dash divided by ab, right? And we have already seen that a dash b dash divided by ab is also equals to cb dash divided by cb, right? So from there, I hope you understood this, right? This is nothing
Yes
but
yes
particular statement, this equation. So from there, I have the formula for magnification now. You just have to substitute the values. So this a dash b dash is, uh, let's say it is the size of image. So and it is on the top.
so plus h
Yes, it is on the right hand side. Let us represent it by plus I. Next is AB, that is object.
minus o
This is on left hand side, so represent it like this. Okay, coming to this CB dash, sorry, CB dash, that is on the right hand side, and it is the image
plus
distance,
h
and
sorry plus v
is
minus u
CB is minus U. Done. So that means this magnification, which is equals to
minus v by u.
I by O, that is nothing but V divided by U,
Okay okay yeah
right? Because you missed the second step, that is M is equals to plus I divided by
by
minus O.
oh,
Here, M is
yeah
this,
yeah
right? M is A dash B dash divided by AB, so that is nothing but plus I
yeah,
divided by minus O. Just now we have seen, so that is equals to plus V divided by, I mean, it will be minus of I by O, so that is equals to plus V divided by minus U and minus of minus U. So that is equals to plus V, or simply magnification is equals to the image distance divided by object distance. This is magnification. So you have got magnification in terms of V and U, and we know that 1 by V is equal, sorry, 1 by V minus 1 by U
minus
is
1 by
equals to
u is
1
equal
by
to 1 by
F.
f.
So we have to find what? We have to find V by U. So that means if you multiply this entire thing by V, what will you get?
V.
You will get 1
1
minus
by
V by
v by
U
u.
is
Equal
equals
1
to
by
1 by F. So that
so v
means
by u is
V by
1
U
minus 1 by
is
f.
1 minus V by F,
F
or simply F minus V
minus v by f.
divided by F. Second, if the same formula, that is 1 by V minus 1 by U is equals to 1 by F, if you are going to multiply it by U, so what you will get? You will get U by V minus 1 is equals to
Minus
by
v.
F.
Yeah.
So that means U by V is equals to
Plus
1
u by
plus
f plus 1
U by F, which is equals to F plus U
plus u.
divided by F.
That you inverse it.
1 minute, 1 minute. U by V minus 1, because we are multiplying by U, so into U by F. So that is
Don't need to
V.
reverse it because it is v by u.
We'll reverse that. But before that, I think there is some problem in the sign. Anyways, U by V is equals to 1 plus U by F. So F plus U by F. Yeah, got it. Okay. So that means
Correct.
from here, what is V by U? V by U is equals to F divided by F plus U. So now for magnification, you have these three formulas. All are the formulas for magnification. First one, if you have U and V. Second, if you have F and V. Third, if you have F and U. Is that clear? The linear
Yes, sir.
magnification formulas. Now the last one is the power of lens.
1 by f
Yes, power of lenses uh, represented by power, and this is equals to 1 by F,
in meters.
right? So yes, obviously it will be in per meter. F is in meters,
Yeah,
so the unit will be per meter.
per
But
meter.
especially for power of lens, we have this particular quantity
D.
has a special
Diopters.
unit, that is diopter,
Diopters.
or simply D. So that is the power of lens. So that was about the refraction through plane
Curved
surfaces,
surface.
refraction through curved surfaces, and we have also seen the theory of different things, basically how the lens formula and the magnification, linear magnification formula. Okay, the next part of this chapter deals with these refraction only, but through a prism. So we'll try to finish that now, that is refraction through a prism.
This